Hello and good morning to everybody. My name is Bernd Bayer. I'm a senior solution architect with Libelle, also VP. I'm joined by Vamsi Mailabarapu. He is a senior technical consultant and also our service delivery manager. We're going to talk today about system refreshes, specifically around the SAP HANA platform, specifically around snapshots. And our webinar today is a bit tilted towards the AWS cloud platform because we're going to show a demo using AWS resources. So this works great in AWS, a lot of opportunities, but it doesn't have to run on AWS. But the presentation is a bit tilted towards the Amazon Web Services. So I want to thank everybody for making time. The highlights and the topics we're going to address today is about system refreshes from a generic perspective. What is the idea of a software-defined refresh? What you need to automate the workflow, and then the specific workflow, and specifically pre, copy, and post-processing tasks. We look at HANA DB snapshots in particular. If you do refreshes, you have to copy the database. HANA DB snapshots is one option. You can also do backup and recovery. Also, if you are not yet on HANA, snapshots work for other databases as well. And the whole process, of course, works for other legacy databases, Oracle, DB2, MS SQL Server, DB2. Anything that SAP is supporting is supported by the process. One couple of snippets about the multi-tenant HANA DB installations, how we do the PDLS acceleration, and then the main part of the presentation is looking at an end-to-end refresh on AWS during the presentation. If you have questions during the webinar, there's a Q&A feature in your GoToWebinar interface. We have 10 minutes at the end of the session to address all and any questions you have, or you can also reach out to us simply by replying to the invitation of the webinar, and we can address your questions there. With that, I would like to get started, and again, thanks everybody for joining. Libelle is the name of our company. We are headquartered in Stuttgart, Germany. Vamsi and myself are based in our Atlanta office. We have been developing and marketing and selling enterprise software since the mid-90s. We have more than 1,500 installations at more than 400 corporate customers, and we have some of the largest SAP installations worldwide as our customers. 80% of our business is carried by SAP, so we are a company that is very SAP heavy. Our portfolio, we are a software company. That means we are licensing software, selling software. In the middle, you see what we're going to talk about today, Libelle SystemCopy. There are other iterations and add-on of this SystemCopy solution, which is a client copy. If you do system refreshes and want to add client copies, we have an add-on for data masking, and we have an additional add-on for automating the copy phase, which is already included in the HANA version of our software. And then we have other software around data replication, which is a lot used for cloud migration, for example. And we have products around SAP landscape management, data masking, IDOC monitoring, and SAP monitoring. System refreshes, as a definition, is the standard homogeneous system copy. Again, we also do client copies as part of our repository. We don't do data slicing and subsetting. It's always a full system copy. So it's either a homogeneous system copy or a client refresh, but not the data slicing. The system copy process grew to be fairly complex, very time intensive, and it sometimes takes days. For some customer, it takes weeks still to do the system refresh. It's highly repetitive, it's highly manual, and it's a great way of using an automation software to automate the workflow, mainly because the resources who have to do the system copy are very expensive, and they are also in very high demand internally. So instead of having a senior basis admin doing a refresh for 2 weeks, he could work on the next generation architecture of your SAP landscape. So it's something where you can use automation software to provide value to your business. So we believe in automation. Automation means, in our case, we have a piece of software that sits in the middle of the process, which is defining the refresh process. What we need for this is a standardized workflow. And the nice thing about SAP, it is on the one side very complicated. On the other side, SAP is extremely organized. So the workflow is standardized by SAP. And then we have in the workflow, we have a lot of pre-SAP and post-SAP steps, like exporting RFC settings, exporting user tables, running PDLS, that would be pre and post-processing. And then for the database copy mainly and the provisioning, we have operating system tasks, database tasks, storage tasks, masking tasks. And we want the team, you as a customer, focus on execution of refreshes, exception handling, and not of the actual doing of running T-codes over and over. That to an introduction, why we think software-defined refreshes make sense and the value to the business. Let's look at the Libelle SystemCopy software. So we have a piece of software, it's called Libelle SystemCopy, that automates and accelerates system refreshes. And we do this from the very first step of initiating a refresh to the very last step of running PDLS and TEMSE. We have a repository of almost 500 tasks by now that is doing the providing a standard workflow for different scenarios. So there is a repository for BW systems. There's a repository for ECC. If you have live cache, there is a repository for that. And the SystemCopy software overall has these 3 components. It's the automation framework. It's a task repository, which is the workflow to execute a system refresh, and the management console to do the management of the system refresh. So the separation in these areas is important because there are automation software products out there that give you a framework, but they don't give you the workflow. So they give you a nice automation software, but you still have to develop the complete workflow. Libelle SystemCopy comes with the workflow. So what is the process of doing a system refresh? And the interesting or not so interesting thing, it's kind of implied, the HANA DB refresh is almost the same as the standard refresh. So from my estimate, 80 to 90% of the steps of a HANA refresh are the same to Oracle refresh. Of course, the database copy is completely different. It's much easier with HANA, but the pre and the post steps are the same, plus adding specific steps for the HANA database. And also, if you use S4 instead of Suite on HANA, there are specific steps which would be specific to S4. But overall, refresh process is the same. We start with pre-processing, exports all settings we want to keep. We do a database copy from source to target. We do the import after the database copy. And optionally, we can do the masking that data is obfuscated after the refresh. Oops. Overall, our automation framework supports different task types. So on the screen, you see on the left side, we do table operation and database operation. This is how we execute specific tasks like RFC table export and import. We have tasks for shell scripting, so we can do Windows PowerShell or any Unix shell. We have SAP functions running ABAP programs or reports or any R3 runs, and then manage the refresh workflow that we can sync tasks between different refreshes. So if you do ECC and BW together, we can sync that and update the customer about the status by email. We have always had and have a specific implementation for PDLS. So overall, PDLS became faster with HANA. It still leaves a lot of space for improvement. So we implemented an ABAP-based process to trigger the PDLS much faster by identifying large tables, using indices on those large tables, which dramatically accelerates the PDLS, specifically with HANA. Since everything is in memory, the execution is much fast. If you add much faster, and if you add indices, it is extremely fast. So we see PDLS runs of 30 minutes, 1 hour, maybe 1.5 hour max on some very large systems. But really nothing in the workflow with HANA is taking up too much time. Our software is self-documenting and reporting. So when we do a system refresh, when we do a new project, we typically come in and we see a 50-page or 200-page Word document of this is how we do the system refresh. Software that is defining the refresh is self-documenting, so you would get all the reports out of the software. So the software is replacing the workflow, which is the documentation, which is interesting as a perspective. You don't have to manually update your processes. So I want to look specifically at the showcase how we do the HANA DB on AWS with snapshots and spend some more time around the HANA. So the showcase we're going to show you in the next, starting in probably 5 minutes, is we have a production system running on HANA. We have a QAS system running on HANA. This is Suite on HANA with the EDIS system. And we're going to refresh this QA system. We do a pre-phase. We export all the existing settings. And then we would follow up with a copy phase. So we have a HANA DB production system that is up and running. We have a QA system which we want to refresh, and we need to transport and copy the production database to the QAS database. There are a couple of steps we do as this copy phase. We're going to shut down QA, detach the disks in order to do a snapshot of production, and then mount that snapshot on the QAS system. And then we do the database post steps. These steps, pre-copy, and then the sub-steps, A, B, C, D, and E, are all automated and encapsulated in the automation software. And then after then, we do our standard post-processing, do the imports, and run the PDLS. When we do the snapshots, you can do snapshots in 2 ways. You can just snapshot the data, which is much simpler, and it usually serves the purpose. You can also integrate a point-in-time recovery with the snapshots. For our showcase, we decided to go a simpler route and simply do a snapshot of the data mount point and snap it to the QAS database. Overall, we looked at HANA systems and we like the snapshots a lot because SAP is providing specific snapshot features and it is fast, it is great, and it provides you a high acceleration of your system refresh. However, we also see that HANA backups and HANA restores are extremely fast. So a snapshot might take with pre and post processing 30 minutes or 1 hour. A backup restore might only take 2 or 3 hours. So you could consider, you don't have to do a snapshot. You could also do a backup restore. They are fairly fast. Overall, the process is similar in terms of pre-copy and post-copy. And another reason we like a backup restore is if you have a multi-tenant database, and this is important for you to note and keep in your mind. SAP HANA by default comes with a multi-tenant installation. You always have your tenant database and your systems database. This would be 2 databases, but it kind of is still a single tenant because it's only the system database and 1 tenant. If you have 2, 3, 4, or 5 tenants in the same HANA installation, currently snapshots are not supported by SAP. And when I say snapshots are not supported, there are two kinds of snapshots in the process. One is doing a snapshot on the HANA DB, and the second is the storage snapshot. And putting the snapshot on the HANA DB is not supported currently for multi-tenant HANA DBs. That's why we still propagate the backup and restore, probably going to be different as we go forward. The test landscape, and I'm going to hand this over in about 2 minutes to Vamsi. This is what we prepared, pre-built. We have an SAP system, 2 of them, one production, one QA, sits on a HANA database 2.0, 185 gigabytes. This runs on AWS on some fairly big machines, not the biggest they have, but maybe it is the biggest, but it's 32 CPUs, 244 gigabytes memories. We have GB2 disks, which are now we do rather IO2 disks, but GB2 disks serve the purpose. We have SystemCopy installed. We use EBS snapshots. We have LSC GUI connected, and then we run around I think 220, 230 steps. Overall, the execution time for the refresh we show is 126 minutes. We have 7 check tasks, 58 pre-tasks, 13 copy tasks, 136 post tasks. So these are all the steps which are executed automatically. And then you see the execution time, 1 minute for checking, 6 minutes for pre, 67 minutes for copy, including the snapshots, and 52 minutes for post-processing. And then we pre-recorded this 126-minute refresh and took out all the wait times and compressed it into a 28-minute recording, which we're going to walk you through next. So with that, again, if you have questions during the presentation Vamsi is giving, just use the Q&A feature. This was a brief introduction into the architecture, and we're going to look at the live presentation now. So I'm going to hand over the presentation to Vamsi. Vamsi, you should see it on your screen. If you can share your screen, that would be great.
Thank you, Brent. So I hope you can see my screen with the HANA Studio open.
Yes, Vamsi, all good.
As you see here, I have I'm playing the recording now, and as Bernd explained, I will be going ahead or walk you through the refresh process. First, I want to walk through the system. So we see here the production database and the Q database, and it's HANA 2 SP02 here, and I have both the databases listed in my HANA Studio here. And I also have 2 SAP sessions open. On the left, you see the PRD. On the right, you see the QA system. And both are, if you go to the system information, so the database on this is HANA database on both the machines, as you see. And the sits are different than the SAP sits. So it's QDB and QAS and PDB and PRD. So let's now go back to the SystemCopy GUI interface. So this is the refresh that we'll be running today. So the configuration name is LSC PRD QAS. And we have the workflow defined. But before we go ahead and do that, let me show you what's happening in the background. So I have, I'm grepping the processes. So for each system, there'll be 2 processes running. There is a process which runs as PRD ADM on the left-hand side. On the right-hand side, I have 2 sessions open here. You have the QA's ADM, 1 process running with SID ADM and 1 with root. The reason being I want to use the snapshot technology. So to mount and unmount disks, I need to have the root permissions as well. So I run 2 agents. They are lightweight agents. And now I log into the GUI interface here, and I will walk you through the configuration before I kick off the refresh. So I define my systems here. It's still loading the configuration, so it takes a bit of time. Okay, it's loaded now. So I walk you through the systems. So I define all my systems here, my targeted system and the source system, and I define roles for each system. So in this case, it's HANA QAS, which you're seeing now. So it's defined as target SAP and target DB. And most of the information here is automatically populated, but I still have to input the client information. In this case, it's an EDIS system, and I'm refreshing client 800. And I provide my database connection information. And I do the same thing for all the other systems, the PRD and the QAS and the SUC. Then these are the different task types that we have. As Bernd explained, we have close to 500 different tasks, and we handle close to 70 different transactions. There are 4 phases mainly. The check phase, which is basically checking the validity of the systems. It's comparing the source and target systems. And then we have the pre-phase, where we run a lot of exports. Most of them are self-explanatory. You could identify them using the T codes that you see in the description. And all these things are happening in parallel when we start the process, which you will see now. And then we have the copy phase. In the copy phase is where, as Bernd explained in his presentation, we'll be using the HANA Amazon Snapshot technology. So I'm going to list the disks in the inventory steps. The step 1 and step 2 of copy is basically checking what disks are having the data volumes. And then I trigger a snapshot on production and then freeze the production file system, snap the disks, create volumes, and then stop the HANA database on the target system, detach and attach the new disks, and then restore the system DB and restore the tenant database. So once copy is done, it's basically the post process where we start putting the data back that we exported in the pre-phase. And in the post phase, we put all the data back. Again, everything is happening in parallel. And then we perform PDLS and all the post-processing activities. PDLS, again, there is a lot of improvements that we brought into the PDLS process. We do use a standard PDLS, but again, there are some additional steps that we perform. If you see the post tasks number 148 to the 157, that these are the tasks which are doing all the PDLS optimizations. You will be seeing that in the execution report. I'll be talking more about this when I pull up the reports and things like that. But first, without any much further ado, let's go ahead and start a refresh. So I'm starting the refresh now, and it will first start with the check phase where it will do the validations I was talking about. It makes a comparison between the source and target systems, and then it will go ahead and kick off with the post phase, the pre-phase, sorry. So with regard to PDLS, I will be pulling up the report shortly, but again, there are a lot of optimizations that we have done in terms of indexing, in terms of parallel execution, and spinning of multiple jobs. Now, as you see, the free kicked off. I'm going to pull out the SAP GUI here and show you what exactly happened with the task SMO2. It's supposed to broadcast a message, and you see that it has broadcast a message here that system copy will be executed. The task itself is highly customizable, so I'm going to drill down on the task and show you what exactly we do in that task. If you look at the task, each task has the same format. It has a unique identifier. It has a name and a detailed description of what the task is doing. And then you can define with which client the task has to execute. You can either define a default client, or you can define with all the clients. And then each task is basically categorized. By default, we categorize it into the default category. If not, then we categorize into a specific category. And then each task has a phase. It's, in this case, the pre-phase. The location of the task is 5. It's a LaBella shell script. It's our own scripting language. It's supposed to execute on target SAP system. And then here is where you customize the task. You basically define the message that you want to do, when is the message expiring, and when is the message getting deleted, and things like that. And once, as I said, this is highly customizable, and then we have a standard return codes that we look for. Code, of course, is something that you cannot see, but let's look at the log files, and you see that we have executed the task with that values, and it says message is successfully added. And we take care of the users, we take care of the bad jobs, we take care of close to 70 to 80 different T codes that most of the basis administrators talk about in terms of post-processing. Once the database is copied, they have to readjust the bad jobs, printers, users, RFCs, sector settings. So we basically export all this information out in the pre-phase. And user export typically takes some time depending upon how many users you have in the system. So let me go ahead and show you things at the OS level. Let me grab for example, LSC. And as you see, when there are multiple R3 transactions that kick off when we are exporting the tables out. So you see, if we go back now to the graphical user interface, you would be seeing that there are multiple exports happening in parallel. And that is the reason why the export process is very, very fast. Even the largest systems that we have seen, close to 100 terabyte databases, the export process takes not more than a couple of hours. In this case, as Bernd explained in the slides, the export process took not more than 6 to 8 minutes. So once the exports are done, we also export the variants. That's one of the last steps here. We bring the system down. So it's again, the whole workflow is out of box and it's highly customizable. So if you want to deactivate any steps, it's fairly quick. Most of the customers would prefer stopping the system manually because they don't want to do their validations. You could very much go ahead and do that. But we have a standard process of bringing the system down in the right way. So we list out all the message servers and the app servers, and then we bring all the app servers down and bring the system down gracefully. So let's do a quick check here and see if the system is going down. So the system is down now, and now is where we will be looking at the copy phase. So it's still waiting. So yep, it's done now, and now we will be hitting the copy process. So as you see, the eye icon there, that is the icon which will say that the process is waiting. You can basically go ahead and remove that wait if you would like to. And now I'm going ahead and continuing with the system copy process. So the copy is happening now. And first, as I said, we'll be listing the source disks and the target disks. And now we go ahead and trigger a snapshot on the production system. So if you look at the system, I have listed totally 6 volumes. And if you look at the files, that's the instance number, that's the volumes that are listed. And it's fairly quick, the whole process, inventory and the list. I'm now kicking off a snapshot. As you see in the Amazon console, the snapshots are being kicked off. And if you're kicking off snapshot for the first time on the disk, it's going to take some time, but I've tried this multiple times, so the snapshots are fairly quick. So the snapshots are getting created now. And once the snapshots are done, we just go ahead and unfreeze the production file system and let the production do its work. And then we go ahead and create volumes out of the snapshots. So snapshots are done now. So let's go ahead and see. So the volumes are created now. And we will go ahead and now bring the HANA database down. So this is the moment where we go ahead and bring the HANA database down. So stopping the HANA DB is done. And now I'm unmounting the target volumes. So the existing disks, I am detaching them, and I'm waiting for them to be detached completely because I don't want to attach them when the disks are still being detached. And now I am going ahead and attaching the new volumes. So they are attached. And these steps are fairly quick. If you see, none of the steps take more than a minute or two. And this is where I'm starting to restore the system database. So the system database restore process is happening. And it's basically kicking off the standard script, the Python script that SAP provides. And it's done with the restore process of the system database. So let's go to the HANA Studio and check. So I'm refreshing it here. So the system database is available, but my tenant databases are still not available. So now I will go ahead and start with the tenant database restore. So the tenant database restore should kick off shortly. And the tenant database restore took some time for me. Again, this is pointing back to the fact that I selected GP2 disks instead of IO1 disks. IO1 disks are fairly quick. Here, I cut the thing off, but it took close to an hour for me to restore the tenant database. So tenant database is restored, and now I'm continuing with the post-processing. So the tenant DB is restored, and now I'm changing the passwords. I'm cleaning up the work directories, and now I'm doing all my post-processing, like deleting the jobs that came from production and putting the jobs back, and putting the license back, putting the RFCs back. So all these things, again, they happen in parallel. Same like pre-phase. And at this moment, SAP is still not up. SAP is still down. The reason being, we don't need SAP up because all of these things are happening using R3 trans. So all I need is the database to be up. So that saves a lot of load on the database. So all these things will be happening fairly quick again. So as you see, things are happening in parallel. First, I flush out all the data. So all the deletes are happening at once, and then all the imports happen at once. So if there are some client dependent entries, then we flush out the data for all the clients. So now the imports are happening. There might be some imports which run for a while. For example, the statistics, ST03 settings, they take some time. But again, that's a choice that we give to you. If you don't want to import ST03 settings, you could go ahead and deactivate them. And you could tweak the whole workflow. If you think that this workflow is not working, which is mostly not the case, you could always go ahead and define your workflow. We provide you all the bells and whistles of how to communicate with database with SAP using R3 trans or ABAPs or RFCs. So we have all the building blocks for you to define your own workflow. So once the imports are all done, that is where we bring SAP up. So by the time your SAP system is up, you already have 90% of your configuration back pointing to the queue system. So there is no way that the bad jobs kick off. There is no way that the RFCs are pointing to production, because everything is done when the SAP system is down. So as I said, ST03 is taking some time here, but it should be fairly quick. I think I cut it off. And then we import the variants and we bring the system up. And once the system up, there are things that we cannot do while the system is down, like the user imports and SCC7 post-import processing. That has to be done when the system is up. So that is where we need the system up. So we bring the SAP system up. We'll check that shortly. And we'll go ahead and so that is where we will, I think there was some, just a minute. Yeah, so we are bringing the system up here, and now the system is up. So if you see the log files here, the system has started, and I'm opening SAP GUI now to see if the system is really available. And we will put the users back. Again, the user import process might take some time, and it will be going ahead and doing the post-import processing. And we will be, let me check the user import logs. So we make sure that user import process is running, and now we are checking the so I'm checking the transport to see if the user import transport is done. And once the user import is done, it should start processing the, yeah, so that's a transport, and we have put the users back now. So I have to see it should now kick off the SCC7. Yeah. So this is all user import checks. I'm just looking at the transport. Yeah, so that's the transport, the SCC7 happening there. So I have, so I'm just checking the SCC7 log here. So user import is done. It took like 4 minutes for me in that case. And now the SCC7 log is what I'm checking. So the transport, so it's done, and now I'm done with the users imports, and now they're basically, we are in the end. The only remaining big step is the PDLS. So you see here we are doing the PDLS part. So the way that we do PDLS is in a multi-pronged approach. The first thing that we do is we identify the tables that are required for conversion, and then we put those. We select the big tables. Again, the selection criteria is something that you can define. If you think the tables with more than 1 million rows need to be selected, you can define that here. But we select all the big tables and put them in the exclusion list. So that's the next step. And once we are done with that, we drop all the secondary non-unique indexes for those big tables. After that, the next step is to create indexes on those big tables. So we always target the big tables. So we drop the secondary non-unique indexes, we create indexes on those big tables, and then we run the standard PDLS report, our PDLS map, on the tables which are not big. So all the big tables, we have put them in exclusion list. So we run the standard PDLS, it finishes off fairly quickly. And again, the standard PDLS is modified here. We will be hitting the same table with multiple conversions. So if you have PRD to QAS, if you have BW conversions, if you have SCM conversions, we don't have to do it multiple times. In a single go, we hit all the conversions at a time. So one table is hit only once. And once we are done with the standard conversion, then comes the job set. So this is where we take the biggest, the exclusion list, and for each table in that list, we spin off a job in SAP. I think I should have shown that, but I don't have that on my recording here. But if you are interested to see more on this, I could definitely go ahead and show that. So once the PDLS is done, we then drop those indexes that we created, and then we recreate those secondary indexes that we have dropped back, and then we restore the PDLS exclusion table. And with that, if you see the runtimes there, they are realistic runtimes. I mean, yes, this is an EDS system close to 200 gig data, but they have done some huge number of conversions in the background, which I would be showing you in the reports with the indexes. I think there were close to 40 indexes that got created, and it was fairly quick. So once the PDLS is done, it's basically importing the central user administration tables, the partner profiles, and then we release the jobs. So that's one thing which I want to point out. We put the jobs in suspended mode till all the activities by the tool are done. So releasing the jobs is one of the last steps in the complete workflow. So once we are done with this, typically it will provide you a report. If you see the top button there, the report, so that is where we create a execution report, and the execution reports are created automatically depending upon the profile, but I would go ahead and pull out a simple execution report for now. So just a minute. I'm sorry. So this is the execution report that I want to show. So it's as you see, it's a 450-page document that gets generated automatically after every refresh, and it lists out all the tasks that got executed, what's the duration of each task. It also lists out effective duration of each phase. In this case, as you see, the pre took like 6 minutes, and the copy took close to 1 hour 7 minutes, and the post-processing took close to 52 minutes, including the PDLS. So I want to show the PDLS indexing part here shortly. So let's see. Yeah, there you go. So that's the PDLS indexes that got created. As you see, the report is documenting every minute detail that the tool will perform. So in this case, as you see, this particular task is supposed to create indexes on the big tables. And if you see that they are close to 40 to 47 indexes that got created on the system. And these indexes are temporary indexes. Once we are done with the conversions, we drop these indexes. With that, I think I'm done with my demo, and I would give it control back to Bernd. And Bernd, over to you.
Great, thank you, Vamsi. And as you might have noticed, Vamsi had to rush a bit in between because we showed you a full refresh within 28 minutes. Now, it still took 126 minutes, but realistically, in order to explain all the things that happens, we should spend 60 minutes, probably in a workshop, maybe 90 minutes to go through all the steps. But I tasked Vamsi and we talked, let's fit a complete refresh into a webinar in 30 minutes just to show the completeness of the refresh. And Vamsi, great job putting that together. But as you saw, there was a 1 hour copy. So we took a lot of steps out in the video recording that was running in between in order not to just sit there and wait for the copy to finish. But this refresh took 126 minutes, a 2 hour refresh. That's, of course, that's fast. Realistically, when we look at system refreshes, I think as customers go to HANA, as they automate the copy phase, HANA is much faster. It has much bigger hardware, much more CPU and memory, so it's overall much faster. It's also much more standardized. It's not different databases, Oracle and log files and DB2 and different log directories. So it's more automatable in our book than other systems. The infrastructure is much better. AWS Snapshot helps a lot. So we saw and see refreshes done in 6 to 8 hours. I think targeting a refresh with HANA with 12 hours is not unrealistic. I think it can be done faster because there's really nothing too much that is taking up the time. So what I want to do next, and we might finish a bit early depending on how many questions we get in. I want to do a quick summary. So overall, we talk about the software-defined refresh. So this is a classic automation approach. We have software that is defining a workflow that is defined once and then executed over and over and then optimized in between. So the benefits are it's reducing manual overhead dramatically. So by default, we say it should be about 50% faster or should execute double the time, and it should take half the resources to execute a refresh. And we usually overachieve that goal when we go into implementation. The process is much more standardized because automation only works when the process is standardized. So it forces standardization. It also forces everybody to follow SAP standards and don't bypass processes that SAP is setting. So it forces everybody to follow standards. It's reducing costs. It becomes much more predictable and consistent because it runs the same every time. So unless you do some dramatic landscape changes, it should execute the same way over and over. It's traceable. So there are reports. If something goes wrong, you can go back in the report and say what was executed, what is the log file. So in the report, Vamsi was showing each task produces a log file. Each log file goes in the PDF report. So you have that information sitting around forever. It's reducing risk. It's allowing you to deliver the refreshes faster, and you can basically automate much, much more. One of the results we are seeing in the past, many customers tell us there is a negotiation between the SAP basis team and the business on when they get a refresh, how long it's going to take, and then they have to compete with other priorities. Once the process is standardized, that negotiation is much easier because the team knows it's predictable. It's going to take a day or 2 days. And typically there are more refreshes executed up to a point where customers refresh this every month. We have a customer, he refreshes every weekend because it's the same process over and over. So I want to go ahead and now open the Q&A session, and we have a couple of questions already in, if I see that interface. And if you have questions, just use the Q&A features. Want to spend about 10 minutes with user questions. So the first question maybe for you, Vamsi. In a BW system, how long will PDLS take using Libelle for a database size close to 10 terabyte?
It's a tough answer, Brent, because it all depends upon the resources that are available for the system. I can give a rough estimate based upon the experience that we had with one of the customer, where they have a 1 terabyte system, and the PDLS conversion took close to 45 minutes there. So it all depends upon how many resources, how many jobs that we can kick off. If you give the background jobs that can be kicked off as 50, we can spin off 50 PDLS conversions at a time. So it all depends upon how many conversions, but it will be fairly quick, and there are a lot of optimizations in the process that we have defined.
Okay. Next question, Vamsi, I let you answer that as well. The system refresh with snapshots, does it work for multi-tenant databases? I have 2 HANA landscapes, HANA 1 Service Pack 12 and HANA 2 SP03, both are multi-tenant. I think I mentioned it, but I'll let you explain it maybe in your words, what the issue is there and why it's not working.
Yes, it is possible as long as you have only one tenant database. If you have multiple tenants other than the system DB and the tenant database, one tenant database, the snapshots are not going to work. That is a limitation that is currently there. But if you have a system DB and tenant database, like what you see in my in the demo, we have a system database and we have one tenant database, and the snapshots work perfectly fine because the system DB holds the metadata of each tenant database. So I cannot just refresh one tenant database. So I have to refresh everything at a go. So that's a limitation, Brent, but that's implied.
Vamsi, how do you freeze another question, how do you freeze the production database during snapshot creation on AWS?
So there are 2 layers of freeze that should happen. The first freeze comes from HANA itself. So HANA provides a command where you can freeze the HANA database, but to maintain consistency at the volume level, I also recommend freezing the file system itself. In this case, SAP or Amazon recommends to use XFS file system. So there is an XFS freeze command. You trigger that command. It happens in seconds, so it's fairly quick. So you do this freeze at HANA database level, and you do the freeze at file system level, and you don't have to wait for the snapshot to finish off. You just trigger the snapshot command on the Amazon using the Amazon API. Once the snapshot command is triggered, rest of the consistency is taken by Amazon. You can immediately unfreeze and let the production continue its work. And again, it's like probably 5 seconds job. It's not going to affect any of the activities on production.
Okay. Next question also for you, Vamsi, new to HANA-DB, but is it still necessary to create temporary secondary indices on some of these tables if they're columnar tables versus row-based tables?
That is the same doubt I had as well initially, Bernd. I was like, why do we have to create indexes? It's all column and row based now. So, but the indexes have improved performance drastically in terms of the PDLS updates. So yes, we would recommend creating indexes. And again, this is a SAP standard function module which we use to create index. So if there is a conflict, it would not be created.
Okay. Next question I'm gonna take myself. Will the slide deck and recorded webinar will be made available to us? I missed the first 15 minutes, and good content here. I like that. So yes, it is being recorded. We're going to convert it and put it on YouTube sometimes this weekend, send out a link. The next question, are there standard templates for ECC, BW, and CRM? How are they standardized to ensure it follows SAP best practices? I can probably pick that up. So we have our task repository. It's almost 500 tasks, and we follow the SAP refresh guides religiously. So we don't want to bypass what SAP is doing. We have our own process, but we follow SAP standards. So when you go into GUI, you basically say, this is, for example, a BW system, and then there's reports that you have to run on PDLS. I think there are special conversions for BW. So it is following SAP standards, and we have our repository for this environment. Next question, Vamsi, back to you. Does it take twice as much time to create AWS snapshots and then to create new file systems out of those snapshots?
No, it's the snapshot creation itself. The initial snapshot itself will take time. So that's the reason why you typically take snapshots as part of your backup process as well. But again, every subsequent snapshot that you take is basically a delta. So first snapshot might take an hour, but the next snapshots, they take very little time. And volume creation, it just happens in seconds. So as you might have seen, the volume creation step in my case, I have to create 5 volumes out of the snapshots, 6 volumes. It took me 40 seconds. So it's fairly quick.
Okay. So there was a question around licensing. It's kind of a specific question, but I take it as an opportunity to talk about the licensing model. SystemCopy is licensed per source system. So if you have one source system, one ECC, you have one license. If you have ECC and BW, you need 2 licenses, and then you always have unlimited targets. So if it's 2 licenses, it would mean it's a ECC and a BW system. Next question, and I like the questions, and I'm glad we have some extra time. We still probably 3-4 minutes for the Q&A. Can RSA1 related tasks be part of the scripting? I call the scripting more tasks because they're more standardized, but scripting, or would that be a manual post tasks? If you can talk about that, Vamsi, what's automated and what's manual?
So RSA1, it's not manual. That being said, I have seen instances where we have to reconnect the settings. Typically, we export the RSA1 settings out and put the RSA1 settings back. But there might be a case where you have to reactivate the connections and things like that. So I would say yes, it's automated, and no, there might be some manual activities involved.
So we export the RSA1 admin tables, but the process of activating the connections, it might be a manual process, but we do have half of that covered.
Exactly.
And
yes.
sometimes all of it, depending on the configuration. The Libelle SystemCopy tool, does it need to be installed on the HANA server in case of a distributed ECC that has the application server on Windows and HANA on Linux? So where is the SystemCopy software go, Vamsi?
So in case of HANA, as long as you provide the client where I can trigger the HTTP SQL, you don't need to install the agent on the HANA database. Probably you're talking about an appliance here. The database is on an appliance and you have multiple databases there. No, for HANA, as long as you interface us with a client with which we can trigger HTTP SQL commands, that's all we need. From the snapshot perspective, yes, we have to do that because we have to unmount and mount the volumes and things like that. So if we have to just do a backup restore, which we very much can do and we have done, we don't need a agent on the database instance.
Great. Next question I'm going to pick up. Can we use Libelle only for pre and post steps? Yes. And a lot of our customers, they already have a established process for the database copy. So we don't have to do the copy. We could do it, but we don't have to. So we have a lot of customers that use us for pre and post, basically automating all the SAP bases and then hand it over to the infrastructure team, and they provide a snapshot or a database copy. Another question, we run 5 system refreshes every time. Does it handle all the 5 systems in parallel? Yes. So we didn't talk about the architecture. SystemCopy has a master agent which holds the configuration, and then there are worker agents going on the different systems. So you have a master for sitting on a Linux server, for example, and then you have a worker on ECC, another worker on BW, another worker on CRM. And then we trigger all the refreshes in parallel. They run in parallel on the respective system. And then we have also sync tasks that they can report back to the master server, that one refresh has to wait for another refresh to complete a phase before the next phase for both of them or all of them is initiated. Maybe this one as a final question, the demonstration, was it done in the same data center, and what happens when source and target are in different data centers? I also going to pick that up. This was done, actually, I don't know, Vamsi, was it done in the same availability zone?
Yes, it's in the same AZ availability zone. Typically, you will be having your systems in the same region with the system spread across multiple availability zones. But you might be having a case where you have the systems in different availability zones. Then we need to have an additional hook there where we have to move those snapshots. If you have the snapshot or systems in same region, then you can spin off a volume in a different availability zone. That's possible. But to a different region, then we have to move those volumes to S3 and then create a volume out of S3.
Great. Thanks, Vamsi, for the answer. And thanks. One final remark. I'm going to be reaching out to the attendees next couple of days if you want to set up a separate session for your team. So if it's only you from your IT team joining, I can set up the same session with Vamsi and me with a live refresh for you and your team. Just reach out either to me or to Vamsi, whatever you prefer. I would appreciate if you do. I'm also going to try to reach out to the attendees. I'm going to send out the link with the recording and slide deck later this week. And I want to thank everybody for joining. Thank everybody for making time. And I'm looking forward to continue the discussion with all of them. And thanks, Vamsi. You did an amazing job during the setting everything up. Thanks, everybody. And I'm going to go ahead and close the call now. Thanks and goodbye.